What could possibly bring down a billion-dollar rocket? It all started with a 50-cent screw, a small, seemingly insignificant piece of hardware. Yet its failure triggered a catastrophic chain of events that led to one of the most expensive industrial failures in history. How could something so small cause such a monumental disaster? This is the story of how a tiny screw overlooked during the assembly process led to the destruction of a rocket that had cost millions to build. A story that reveals how often the smallest, most unassuming components in our most advanced technologies can become the biggest vulnerabilities. As we explore the sequence of events leading up to the failure, think about this. In every industry, from aerospace to everyday consumer goods, what are the costs of overlooking the little things? The rocket in question was designed to carry out an extraordinary mission, something that could change the course of space exploration. Yet, the simplest of failures derailed that mission, leaving engineers, scientists, and investors asking themselves, how could we have missed this? This is a cautionary tale about the importance of every single piece in the engineering puzzle. Join us as we break down the events leading up to the failure of this billion-dollar rocket, starting with the small screw that nobody paid attention to, but everyone should have. If you're enjoying this video so far, don't forget to leave a comment sharing your thoughts on what you think caused this industrial disaster. Was it just a small mistake, or was there a bigger issue at play? If you want to keep learning about these tragic events and how they shape the industries we rely on, hit the like button and subscribe to the channel for more. Now, let's dive deeper into the next part of this story and uncover the full impact of this failure. Before we dive into the catastrophic failure itself, it's important to understand what this rocket was supposed to achieve. This was no ordinary mission. It was a billion-dollar project that promised to push the boundaries of space exploration. The rocket was designed to carry crucial payloads for a high-profile government space agency, intended to further our understanding of space technology and facilitate future interplanetary missions. This mission was a stepping stone in a broader, more ambitious goal, setting up long-term infrastructures in space. From satellite deployment to advanced space experiments, the rocket had the potential to change how we operate beyond Earth. Its success was not just about launching payloads, it was about sending a message to the world that the technology was ready for the next big leap in space exploration. However, beneath the grandeur of this mission lay a critical flaw that no one anticipated, one that would turn this milestone into a reminder of the importance of attention to detail in engineering. The rocket was not just a massive technical achievement, it symbolized the height of human ingenuity, and it was designed with a clear purpose in mind, to launch payloads safely and efficiently, and to demonstrate that we could undertake even more complex tasks in the future. But how could such a grand project, designed to revolutionize space exploration, fall apart due to a single overlooked component? The failure didn't just damage the rocket, it represented a devastating blow to the entire mission and to the trust placed in the engineering teams behind it. In any high-stakes engineering project, it's easy to assume that all the details are being meticulously checked and rechecked. After all, when you're working with a billion-dollar rocket, the assumption is that every part, no matter how small, is given the attention it deserves. However, that's exactly where the problem lay in this case. A tiny screw, seemingly insignificant in the grand scheme of things, was overlooked during the assembly process. The screw was part of the rocket's crucial structural assembly, securing key components that ensured the integrity of the entire system. It was a 50-cent part, but it was responsible for holding one of the most critical connections in the rocket's design. Had this screw been inspected properly, it's likely the failure would never have occurred. Yet, during the intense preparation and testing phases, it was missed, a small but crucial oversight. How did this happen? Could a more rigorous inspection process have caught the error? The engineers and technicians working on the rocket had followed standard procedures, and the screw was examined during routine checks. But in the fast-paced world of aerospace engineering, even the smallest lapses can lead to catastrophic outcomes. In this case, the screw wasn't faulty at first glance. There were no immediate signs of damage or failure, but the way it interacted with the surrounding materials, combined with stress and the harsh conditions during launch, was enough to trigger a chain reaction that would ultimately bring down the entire mission. This tragic failure serves as a stark reminder that in engineering, it's often the smallest details that make the biggest difference. A single mistake, unnoticed in the midst of a complex operation, can have disastrous consequences. The screw, at the heart of this failure, highlights how even seemingly inconsequential parts are vital to the success of any system. When that small screw failed, it set off a catastrophic chain, the reaction that no one could have predicted. It wasn't just a mechanical failure, it was a disaster that cost millions and put the future of the space program in jeopardy. The screw's failure caused a key structural component to become loose, which in turn led to the rocket's critical systems malfunctioning. As the rocket ascended into the atmosphere, everything appeared normal. However, beneath the surface, the screw's failure had compromised the integrity of the entire launch system. The first sign of trouble came when the rocket's trajectory began to shift unexpectedly. Engineers on the ground scrambled to assess the situation, but by the time they realized the magnitude of the problem, it was already too late. The failure of the screw triggered an explosive chain of events. Key components began to break down, fuel tanks ruptured, and in the end, a massive explosion engulfed the rocket, causing it to disintegrate mid-flight. The destruction was swift and total. This wasn't just the loss of an expensive piece of technology, it was a failure that affected the morale of the entire team, as well as the future of the program. A billion-dollar rocket, reduced to nothing but debris in the blink of an eye. This tragic event serves as a brutal reminder that engineering failures, no matter how small they may seem in the planning stages, can have devastating consequences. A single overlooked screw led to the destruction of a project that had taken years to develop, along with millions of dollars in funding and untold hours of labor. One would assume that in any highly technical project, especially one as advanced and costly as this rocket, routine maintenance and safety checks would catch every potential issue before it became a problem. But that's exactly where the failure in this mission occurred. Despite the countless hours of testing and reviewing the rocket's systems, the small screw, the one that ultimately led to the disaster, slipped through the cracks. During maintenance inspections, when the rocket was being assembled, every part was given a thorough review. The technicians, engineers, and safety inspectors followed standard operating procedures to ensure that all components were functioning correctly. Yet, during these inspections, no one noticed that the screw, though seemingly insignificant, was slowly beginning to degrade under stress. This failure highlights a crucial problem that many industries face. Even with stringent protocols in place, there are always opportunities for human error. The maintenance teams were focused on more prominent components and systems, and unfortunately, the small screw was overlooked in favor of more visible concerns. This serves as a lesson that even the smallest and most inconspicuous parts must be given equal attention during inspection. Moreover, it's important to ask, was the routine maintenance protocol sufficient for identifying such a seemingly trivial issue? Perhaps the checks and tests were not as thorough as they could have been. Was the failure of this screw a symptom of a larger issue within the maintenance practices used in the space industry? In high-pressure environments like aerospace engineering, even the most minor oversights can have catastrophic consequences. This incident underscores the importance of continually evolving maintenance procedures and the need for attention to detail, no matter how small the component. The failure of this rocket was not just a technical disaster, it was an economic catastrophe. The impact of the failure reached far beyond the immediate loss of the rocket. The financial repercussions were staggering, with the mission costing billions of dollars, all of which was wasted in an instant. But it wasn't just the money that was lost. The technological setback was also profound. The rocket was a symbol of cutting-edge innovation, built using the latest advancements in space technology. It was designed to carry payloads that would further humanity's reach into space, potentially opening doors to new possibilities in space exploration. But when the screw failed, it brought not just the rocket, but an entire segment of the space program to a grinding halt. In terms of direct costs, the rocket's destruction meant that billions were lost in research, development, materials, and labor. These were funds that could have been used to further technological advancements, but instead, they were wasted on a mission that never reached its intended destination. Beyond the immediate financial loss, the long-term impact on technological development was also severe. With the failure of this mission, the space program was forced to re-evaluate its processes, taking steps to ensure that such a mistake would never happen again. But this came at a cost. Timelines were delayed, resources were diverted, and new projects were put on hold as the industry scrambled to address the issue. This disaster also affected the reputation of the organizations involved. A failure of this magnitude sent shockwaves through the aerospace industry, shaking public confidence in the reliability of space missions. As companies and government agencies dealt with the fallout, the technological advancements that were supposed to take place were pushed back, and the space program faced increased scrutiny. Human error is an unavoidable part of any complex system, but in the case of this rocket failure, it played a pivotal role. The small screw that ultimately led to the mission's destruction wasn't the result of a malfunction or a defective part. It was a mistake, one that was overlooked by the very individuals responsible for ensuring the safety of the project. But how did this happen? Could this failure have been prevented by more careful attention to detail? Or was this simply a tragic result of the overwhelming pressure that engineers and technicians face during high-stakes missions? One of the key issues here is the complexity of the mission. As engineers worked to assemble the rocket, they were juggling multiple tasks, trying to meet deadlines, and ensuring that all systems were operational. In such a high-pressure environment, it's easy for small, seemingly insignificant details to slip through the cracks. This wasn't a case of negligence or carelessness. It was a case of human error in the face of overwhelming complexity. The question we need to ask is, could more rigorous procedures have caught this mistake? Could there have been additional checks or safeguards in place to ensure that even the smallest component was properly scrutinized? Would more time have made a difference, or was this failure an inevitable consequence of a fast-paced, higher-risk industry where decisions must be made quickly and under pressure? In the aftermath of the failure, engineers and project managers undoubtedly went back through the entire process, looking for signs of where the breakdown occurred. Could someone have caught the error before it caused the failure? Could the system of checks and reviews have been more thorough? The answer, unfortunately, is that it's impossible to know for certain. But the failure has undoubtedly raised awareness of the need for continuous improvement in human error prevention strategies. In the wake of this catastrophic failure, the aerospace industry was forced to reflect on the lessons it could learn from the event. How could such a small, seemingly inconsequential component, a 50-cent screw, lead to the destruction of an entire mission? The answer lies not only in the technical aspects of engineering, but also in the way the industry processes risk, ensures quality control, and integrates lessons learned into future designs. After the rocket failed, a deep and thorough investigation was launched to understand every aspect of the disaster. The results were clear. The failure wasn't simply the fault of the screw itself, but of a system that allowed such an important detail to be overlooked. The industry had to take responsibility for this oversight and implement significant changes to prevent something like this from happening again. One of the most important changes was the introduction of more rigorous inspection and testing procedures. Engineers and technicians began to realize that no component, no matter how small, could be considered too insignificant for thorough examination. Every screw, every bolt, every piece of equipment had to be scrutinized under even more intense protocols, with a particular emphasis on parts that were crucial to the structural integrity of the rocket. Additionally, the failure led to a shift in how aerospace companies viewed the importance of redundancy. Where once a single screw might have been deemed adequate, now there was a push for multiple layers of backup systems and redundancies for critical components. This is a practice that was adopted not just for rockets, but for a wide range of industrial applications where high risks were involved. The event also sparked a cultural change within the industry. Engineers and workers began to prioritize open communication, teamwork, and shared responsibility in a way they hadn't before. In a high-pressure industry where timelines are tight and resources are limited, the lesson was clear. No one person should bear the responsibility of ensuring that a mistake doesn't happen. It requires a collective effort. The failure of the rocket had far-reaching effects, not only within the industry, but also in terms of public perception. When such a catastrophic event happens, especially one that involves a massive financial loss, it shakes the trust of the public, stakeholders, and even the engineers working on the project. This incident raised serious questions about the reliability of space technology and the safety of future missions. The general public, who had been eagerly watching the rocket's progress, was initially filled with awe and excitement. Space exploration has always captured the imagination of people around the world, and this rocket, as part of a groundbreaking mission, was seen as a triumph of human ingenuity. But when the mission ended in disaster, it sent shockwaves through the media and the public's perception of the space industry. What was once viewed as a bold leap into the future quickly turned into a cautionary tale. The failure didn't just affect the project itself. It became a symbol of the fragility of space missions and the risks that come with pushing the boundaries of technology. People began to question whether the space program was ready to handle such complex tasks, and whether its technological advancements were truly as reliable as they had been portrayed. Beyond the general public, this failure also had a profound impact on the investors and stakeholders who had poured millions into the project. Trust, once broken, is hard to rebuild, and many of the companies involved in the rocket's development were forced to reassess their priorities. While some investors remained committed to the future of space exploration, others hesitated, worried about the financial implications of another failure. This shift in public perception also affected the engineers and scientists behind the project. Those who had worked tirelessly on the rocket were now under intense scrutiny. They were left grappling with the question of how something as seemingly minor as a small screw could have caused such a massive failure. The pressure was immense, but it also sparked a renewed commitment to improving safety and reliability in future missions. As we reflect on this disaster, one question remains: how did something as small as a 50-cent screw bring down $1 billion rocket? The failure of this tiny component highlights a critical truth in engineering and industry. The smallest elements of a design, when overlooked or neglected, can have the most catastrophic consequences. This event has since become a pivotal moment in the history of aerospace engineering, reminding us that no detail is too minor to be ignored. Every screw, bolt, and piece of equipment plays a critical role in the success of any project, especially when the stakes are as high as they were in this mission. It's a lesson that the aerospace industry, and industries in general, have learned sometimes the hard way. But from every failure, there is an opportunity to grow, adapt, and improve. The changes implemented after this disaster were not just about improving procedures. They were about fostering a culture where everyone, from engineers to maintenance crews, understood the importance of their work and the impact their actions could have on the success of a mission. It was about building a system where small mistakes were less likely to go unnoticed, and where the integrity of every single component was treated as a crucial part of the whole. For those who experienced the failure firsthand, it was a painful lesson. But for the future of the space program, and for industries around the world, it became an opportunity to reevaluate safety practices, design protocols, and quality assurance standards. This failure led to improvements in technology, process, and teamwork, pushing the industry forward rather than halting its progress. If you've made it this far into the video, you've seen the devastating impact a small failure can have on a massive project. Share your thoughts in the comments below. Have you ever witnessed a small mistake lead to a major disaster in your field? And if you enjoyed the video, don't forget to leave a like and subscribe for more fascinating stories like this one. Be sure to watch the next video popping up on your screen for even more industry insights.